Alright, in this video I would like to go over one of the things that we did as a discussion topic earlier and kind of show you what reasoning I was looking for in answering the questions about there being two types of charge. Okay, so the first thing I wanted you to think about is whether we could explain all of our observations with just one type of charge. And the answer is that we could actually get really close with that. So it took a little bit of finesse in order to come up with an experiment you could do that proves that we need two types. Okay, so first I'm going to propose a model. And the model is going to have charged and uncharged objects. Okay, so this is a model that would be really similar to what you would come up with if all you had was just the observation that normally there's no electrical interactions between anything, but if you rub a balloon on your hair, then you see some interactions. Okay, so the balloon is charged, everything else is uncharged. And a way that I want to think about this is, let's say we have charged objects and uncharged objects. Those are the two things we have. All right, and we observe that charged objects and uncharged objects attract. Okay. But if you produced two balloons and you rubbed both of the balloons on your hair, then you would find that those charged objects repel. Okay, so two charged objects repel each other, a charged object and an uncharged object attract, and an uncharged object will have no interaction with another uncharged object. Okay, so a key idea here is that we see both attraction and repulsion in this model that only has one type of charge. So do not mix up the idea of two types of charge with two types of force. We can have many different kinds of charge with just one type of force. We can have many different kinds of force with just one type of charge. It really depends on how we want to set up our model. Okay, so this is a one charge model that has both attraction and repulsion, but this is not the model that we use in physics. There are two types of charge in our normal model. All right, so what's an experiment that we could do that would be inconsistent with this? Well, let's say that we did our two charge model. Well, here we have two types, and I'm not going to call them plus and minus because I think that confuses the issue by making you rely too much on what you assume is true. So what I'm going to do is I'm just going to call the two types A and B. Okay, so what A and B might be is just top and bottom tapes. So you did experiments in the lab with top tapes and bottom tapes, and what several of you found is that if you take those two types of tape, they will attract each other. But A repels A, so two tops repel, and B repels B. Okay, so this is inconsistent with what we saw in the one charge model, in particular because B is different than no interaction with itself. Okay, so these things that I am surrounding with my dotted line, those are the key difference. So if I can find a set of observations, just three observations, where one object repels another object of the same charge, same purported charge. Another object has the same behavior, so repels itself, but then we see attraction between them. Then we know for sure that A and B are both charged, because they both have repulsion, and they are attracted to each other, so they can't be the same type of charge because they have different behaviors relative to each other. Okay, so what about three types? How could we have three types? And in fact, the one I'm about to present to you would work for 17 types or 1,000 types. We could have as many types of charge as we want. We could have A, B, and now C. Okay, so we expect A and B to look the same as what we already did. We don't want to, change that part of the model. So we have attraction between A and B. B repels itself. A repels itself. But now we have this new one, C. And we get to define whatever interaction we want between these. Okay. And we have to be a little careful because if we just pick any combinations, then what we might find is that C is the same as A. Okay, so let me give you an example of that. Let's say that C repels itself, and let's say that A repels C, but B attracts C. Well, in this model, A and C might as well be the same. We can't actually tell the difference between A and C because A repels C, which is the same thing A does to C, and B attracts C, which is the same thing that B does to A. Okay, so A and C could be the same here. But we could come up with a different pattern than this. All right, so here's one that works. Let's say we have A, B, C. Where A repels A, B repels B, and C repels C. Meanwhile, A attracts A, or rather, A attracts B, B attracts C, and A attracts C. So if we came up with a set of observations where we had 3 kinds of objects, and each kind repels its own kind and attracts each of the other kinds, then we would have to conclude there were 3 types of charge. Okay, even though we still only have attraction and repulsion. And you can see now, I think, that we could have many more kinds. As long as each kind repels itself and attracts each of the others, we need to conclude that there are more and more types of charge. Now, in real life, we haven't found anything like this. So, if we went up, let's say, to an Arctic island, and we picked up some weird-looking rock, and we found that that weird-looking rock attracted positively charged objects and negatively charged objects, and if we break the rock in half, it repels itself. Well, then we found a new type of charge, and that would require us to conclude that we had 3 types of electric charge all this time, and that third kind was just rare. It was just uncommon. And this is not the only possible combination. You could have some other kind. In particular, if you allowed no interaction to be in here, maybe B has no interaction with C, and C repels A and attracts itself, or something like that. Like, you could maybe come up with some other combinations that are self-consistent, and any such observation would require us to conclude that we had more types of charge. But, of course, in real life, we have only ever seen evidence of this 2 charge model and not the 3 charge model.